Welcome to another riveting installment of working with rational expressions. Last video we took a look at multiplying and dividing. This one is going to be taking a look at adding and subtracting. I am currently on, I believe it's page 3 in your notes. Yep, definitely page 3 in your notes. Alright, before we can add or subtract rational expressions, which by the way just means, if you look down here, eventually we're going to add and subtract these things. An x squared minus 9 and 2x over that. We're going to be adding and subtracting down there. So before we do that, let's review and make sure we're all okay with adding and subtracting regular fractions. Like right here, for example. In order to add or subtract fractions, you have to have common denominators. These are already the same, and denominators, remember, are at the bottom. So since the 5 and the 5 are the same, you add the two numbers on top, which will give you 4, and you leave the bottom the same. So add the numbers on top, leave the bottom the same. Over here, you have to get them to be the same. So this 2 I can make into 4 by simply taking it times 2, so that's what I have to do up here. You go 3 times 2, so you're going to put, you go 3 fourths plus 2 times 1, which is 2 fourths. You should get 5 fourths. I'm okay with you just leaving it just like that. And the last one. So here we had to take one of them to get multiplied to get common denominators. So here I've got to take both of them. I'm going to turn both of these things into 6. Because that is going to be the least common denominator. We're going to get to the LCD here in a minute. But I have to take this times 2, so I have to take this times 2. Got to take this times 3, so I got to take this times 3. It looks like I get a 4/6 here and a 3/6 here. Subtract those, you keep the bottom the same, you'll get 1/6. That is adding or subtracting fractions. So we can also do that with rational expressions, or meaning if we've got binomials down here, or this would be a monomial, meaning we got 2 terms, 3 terms. As long as these bottoms are the same, right here and right here, I can add these together. I'm going to add the two top numbers to be 2x plus 7, and I keep the bottom the same. Now, don't be one of these people that thinks that you can cancel out this x and this x because they're on top of each other. No, you can't do that because of these plus signs in the middle here. You cannot cancel those out. There's nothing else that you can reduce there, so my final answer is 2x plus 7 or x plus 5. Same thing here. I'm going to subtract the top, leave the bottom the same. Negative 1 over 5x. And this last one here. These bottoms are also the same. So I can add the top, 3 plus x over 3 plus x. Now, since these are exactly the same, now, yes, I can cancel them out. And you will get 1. All right. Being able to subtract, add or subtract rational expressions has everything to do with the LCD. The LCD, which if you remember back in the school, is the least common denominator. It's going to be the same thing here. So before we start adding and subtracting, let's go through a few examples of what the least common denominator is going to be. Like this first letter A right here. Let me start by telling you this is kind of hard to communicate. It's kind of hard to communicate what I'm doing, so I'm going to do the best I can. You're going to have to come in and ask individual questions if you're not sure. But I'm going to first take a look at this 8 and this 2 and say, okay, what can I make both of those just like I did up here with the 4 and the 2 or the 3 and the 2? What can I turn the numbers into first? So I can turn 2 into 8, so part of my least common denominator is going to be 8. Then I have to take a look at my x's. I have 3 of them here. I have 1 of them here. So the minimum number that I have to have is right here. I have to have at least 3 in order to be able to add these two things together or subtract it. So my common denominator is going to be 8x cubed. I got the 8 from the numbers, and I got the x cubed because that's the least number of x's that I have to have in order for them to be the same. Over here I'm going to do the same thing. 6 and 10. I'm going to get those to be the same. I know I can turn that into 30. I have 1x here and 3 here. That means my common denominator has to have at least 3 x's. I got 1y here and I got 2 y's here, so my least common denominator has to have at least 2 of them to add them together. And now we get to the fun ones. I am going to use the term binomial here. That means there are 2 terms separated by a plus or a minus. You cannot, for goodness sakes, please don't do this. You cannot take this times 2 and make it 10 and then switch this to a negative, so then you have x minus 10. No, you can't do anything with the numbers when it's a binomial like this is. So let me give you a hint that I would maybe jot up top in your notes here. Well, we'll get to that hint. You need to, before you find the LCD, you want to make sure that you factor all denominators first. I would maybe even put a star by this so you don't forget. You have to mess with the bottom first before you try to find the LCD. Now here in letter C, I can't factor x plus 5 and x minus 10. But down here in x squared minus 9, I am going to be able to mess with that. I am going to be able to mess with this 2b plus 6. So your first job is to simply make sure that you factor any denominators. All right, once we have everything factored, I have to account for this and this. Since they are both down here in the denominator, my common denominator between the two is going to be both of these parentheses, because I have to account for this and this. So my common denominator here is going to be x plus 5 parentheses x minus 10. Okay, letter D. First one, there's nothing I can do. It's just a b minus 3. The second one, I can take out a 2. So then I'm left with a b plus 3. 1 on top. Now, in order to find the common denominator, I must account for everything that's on the bottom here. Like this b minus 3, that is going to be a part of my common denominator. This 2, that is going to be a part of my common denominator. And this b plus 3 also must be a part of my common denominator. You have to account for everything that's in a denominator. Letter E, I'm going to factor first again. I got an a plus 1. And on this other side, I have an a. Common denominator, I have to account for this a. The good news is once I account for it once here, I also have accounted for it over here, so I can kind of underline them both. I don't know if you want to start underlining things as you use them or not. And then I still have to account for this a plus 1. So I have an a plus 1 down here. That would be my common denominator. And last one, letter F, before we actually start adding and subtracting these things. Number 1, you have to factor these denominators. So I end up with 2x over x plus 3, x minus 3. And I have a 1 over, this will factor in x plus 3 times x plus 3. Now let's talk common denominators. I'll get a different color here. I have to account for this x plus 3. So I know that's going to be part of it. The good news is once I account for one of these over here, I have also accounted for one of them over there. Not both of them. I've accounted for one of them over here. I have to account for this x minus 3. So I can underline that. That I have now accounted for. And the last one is I have to account for this x plus 3 that's left over. So the moral of the story here is if you have 2x plus 3's over here, you better have 2 of them down here. When you have an extra one over here, it only cancels out with one of them on the other side. So here would be my common denominator here. All right, let's get into actually adding and subtracting these things. Flip your notes over to page 4. I'm at the top of page 4. We are going to do these 4 examples here, and then I'm going to have you try these on your own. So, try some of them on your own. Common denominator here, I'm going to take a look at the numbers first, 2 and 3. I know I can make those to be 6. So what I'm going to do is I'm going to split this. I know I'm going to make it 6 something. There's 1x here and there are 2 here, so that means my common denominator, I have to have at least 2 of them in each to add or subtract. The last question you have to ask yourself is once you've figured out what the common denominator is, you have to say, okay, what is missing from here to get me to here? Like it's missing a 3, so I have to take this times 3. It's also missing an x because this only has 1 and this has 2, so I got to take this times 3x. 3x times 5 is 15x. I ask myself the same question over here. What is this missing? What is this missing to get me to that? It's obviously missing a 2, so I got to take this times 2, and this one already has 2 x's, and this one has 2 x's, so I don't have to multiply by any. 2 times 2 will give you a 4. Add straight across on the top to get a 15x plus 4. You leave the bottom the same, so it is 6x squared. You always look to factor and cancel if you can, but since I can't factor the top or the bottom, I am done. All right, example B here. Example 3, number B, letter B. I'm going to factor the bottom first. So I end up with a 5 over 6x squared plus x over. I'm going to take a 4x out of the bottom. That leaves me with an x minus 3. So I'm going to take care of my numbers in my common denominator first. I know I can get 6 and 4 to be 12. I know that I have 2x's here and 1x here, so therefore I have to have a minimum of 2 to put them together. And notice I've been doing the underline thing. I've now accounted for all that. The only thing I haven't accounted for is x minus 3. So my common denominator over here has got to be the same. Now I just have to go through and ask myself the same question that I did before, which is, what is missing in order to get it to be this denominator? Well, this one right here is missing a 2, because 2 times 6 is 12, and it's missing an x minus 3. This one here is missing a 3, and it's missing, don't need a parenthesis, it already has the x minus 3, it's missing 1x, because x times this x will give you this x squared down here. Multiplying these, this turns into 10, x minus 3, and this one will turn into 3x squared. Now I'm going to do a little magic here. I'm actually going to distribute this and combine it with this 3x squared at the same time. So you should end up with 3x squared plus 10x minus 30 over 12x squared, parentheses x minus 3. Now listen very carefully. You would technically, I'm going to be nice, but you would technically have to check this to see if it could factor and cancel with either the 12x squared or maybe if it cancels with the x minus 3. You have to factor to see if something cancels. But I'm going to be nice, and I'm going to tell you here it's not going to factor. We are going to get some examples where it will. This one it will not. 3x squared plus 10x minus 30 will not factor to be anything. All right, last two examples. And then I'm going to have you try these checkpoints down here. I am going to factor the bottom. So I have a 3x plus 1 all over x minus 4, x plus 3. Minus 5. I'm going to take a 3 out of this denominator because I can. So I end up with a 3, x minus 4. All right, common denominator. I have to account for all of this stuff over here, meaning I got to account for this 3. So it's going to have a 3 out front. I have to account for this x minus 4. But the good news is, once I account for this x minus 4, I've also accounted for that one. And then the last thing I have to account for is x plus 3. That's the last thing left to be underlined. So I now have everything accounted for. So here's my common denominator. Minus. Same common denominator over here. Now you just ask yourself the question, okay, what is missing? How do I get to that common denominator? This one is only missing a 3. So I'm going to take the top times 3, which will give me 9x plus 3. This one is missing an x plus 3 because it already has a 3, already has an x minus 4, an x minus 4. It's only missing this x plus 3. Distributing that, I will get a 5x plus 15. The only weird part about subtraction is you have to make sure that you're subtracting this and you got to kind of distribute it over to here as well. So you end up with a 9x minus 5x, which is 4x. You end up with a 3 minus 15, which is negative 12. And it's all over this. Don't forget to refactor if you can to see if stuff will cancel. But I am simply just going to take out, I'm going to take out a 4 from this top to leave me with x minus 3. All over 3, x minus 4, x plus 3. Done. Because nothing can cancel here. All right, last example, then you're going to try those checkpoints. Example 4, letter B. Slide this out of the way. I tell you what, let's get a fun color here. Let's go with maroon. All right, I'm going to factor the bottom. X plus 1 over x plus 2, x plus 2. Minus 2 over x minus 2, x plus 2. I am going to figure out a common denominator here. This has got to be part of it, so I have to account for the x plus 2. The good news is that accounts for this x plus 2 over here. Now I have these two things left. So I have to account for another x plus 2 and an x minus 2. You have to ask yourself, okay, now what are each of these missing? Oops. What are each of these missing so I can get that common denominator? First one. This one here. Let's get another new color. Let's go with ocean. Why not? This one here is missing one. It's got an x plus 2 and an x plus 2. X plus 2, x plus 2. It's missing an x minus 2. So that's what I have to multiply up here. So it ends up being an x plus 1 times x minus 2. This one is missing one x plus 2 because it has an x plus 2 and an x minus 2. So that takes care of this one and this one. It's missing one x plus 2. So 2, x plus 2. I'm going to double distribute right here to get an x squared minus x minus 2 all over. I'm going to rewrite x plus 2 times x plus 2 as x plus 2 squared. X minus 2. Minus, I'm going to distribute this to give me a 2x plus 4 all over the same thing. And my last step is simply to combine like terms, refactor if I can to see if anything will cancel. So I'm going to combine these to give me an x squared on top. Minus x minus 2x is minus 3x. Don't forget this negative here. It has to be distributed as well. So it's negative 2 minus 4, which is negative 6, all over that denominator. The good news for you is that this top cannot be factored, so I'm done. Okay, what I want you to do now is I'm going to put the answers to the checkpoint online. The checkpoint on page 4. Now, I covered them up to kind of give myself some more room to write, but I want you to try the checkpoint on page 4 on your own. It will look like this. It's these two problems right here. I will put these two right here. I will put the answers online. Good luck.